Hello and welcome to the AIDC debate. This is our very first recording. So for those of you who do not know us, we're three geeks located on different sides of the globe who spend their days studying the technologies that make up the AI data center, that make up the process of funding it, building it, and actually the business of monetizing it as well. I'm Vlad and I'm based in London. Manoj is in Kerala, Shen is in Shanghai, and all three of us worked in the industry before we became analysts. And over the course of these podcasts, we'll weave in stories from these times and we'll tell you a lot more about our background. But in the interest of time and in the interest of quickly jumping into the main topics, we're going to kick off the AIDC debate. In our first show, we are going to walk you through what we believe are the key trends to watch for 2026. But before we do that, we really wanted to do a little bit of a myth-busting exercise. So let's start with a few specific things that I thought we can take a look at. It seems like there's a lot of passion in the industry right now. There's a lot of emotions running very high, and I think that there are a few different reasons why, but it seems to me like there is quite a bit of overreaction. There is some overreaction when it comes to the question of, is the AIDC real? Is this economy real? Is this going to happen? And my LinkedIn feedback is filled with debate around this. So let's start with this emotional response. Where do you think it's coming from? And Manoj, maybe you can kick us off.
Sure. Yeah, I think there is a lot of excitement about AI, and this is actually something which we have not seen, I think, in our lifetime before, right? And a lot of people a lot of veterans in the semiconductor industry understand that this is like an investment cycle they have never seen in their life. And a lot of people talk about the industrial revolution and say that this is a next industrial revolution and all that, but people are going crazy about this, and we have Nvidia and Jensen Huang, the poster boy of AI infrastructure now, and whenever he gives a talk or whenever he gives a presentation, people get too excited, and whenever he dines out, even that actually creates a lot of emotions. I think a couple of months back, he dined in South Korea with the leaders from Samsung and Hyundai. And he came out of a restaurant with a bottle of beer in his hand and his chicken on the other hand, and he said, Korean chicken is the best chicken in the world. And the next day, all the Korean chicken retail outlets stock prices are up by 30%. And the Korean chicken processing robots, they were actually trading 200 times the regular trading volumes. Yeah. It's that crazy.
Madness.
So I think there is a lot of drama and excitement out there, but a lot of things is actually real in the sense that the investment and the capacity requirement is actually pretty real. It's actually happening. People are building the infrastructure, brick and mortar, the hardware and the systems in place and powering it and running it. And there is insatiable demand for AI compute. All that is true. So
we're gonna get into whether this is true or not. We're gonna get into that. But okay, so Jensen was actually just on stage a couple of days ago at CES, and it already triggered a drama. One of you, can you walk us through it? So maybe some of our listeners haven't seen it.
So at CES, Jensen Huang was talking about VR 200, and he made one point that nowadays the chips can be cooled by warm water, which is 45 degrees C, and this will actually reduce the demand for water-cooled chillers. And after he said that, all the data center HVAC companies have a very big drop in the stock market. And a lot of people become super panic, and people become emotional. People are like, oh, the cooling market is going to be doomed. So I got a lot of calls and I got emails and questions from journalists. So I was like, so today I just replied to one of them, and I simply tell them that don't be panic. This has been there for years. It's not news. And we know that in the past, when you have AI cooling, you need to have very cold water because there's a lot of heat loss during the process of transportation of heat. So that's why you need cold water to improve the efficiency. But nowadays, because you have a full liquids chain from the chip to the cooling tower, so you don't have to like keep it very, very low temperature so that you can reduce the risk of any problem. So this is not news, and people are being overreacted. And people are being overreacted because Jason Huang mentioned on the stage. But I think if you ask people that works in a liquid cooling company, or if you ask people who designs and build data centers, it's not a news for the liquid cooling data centers. All the chips are running between 35 to 55 degrees.
Okay, so Shen, you say that, but I can't help but interject. The thing is, and I'm going to give you my theory, which is aligned in some ways to I guess what you were trying to say. But yesterday you told me that one of the leaders in chillers in the world called you concerned as well. So it seems like even people who are in the know are almost like drinking the Jensen Kool-Aid, even though they're engineering experts on the topic.
Yes, that's true. So actually, not everybody from leading chilling cooling company knows about what is needed in data centers, because probably they are not frontline engineering people. If they ask any engineering people, they will find out that there's still demand for water-cooled chillers. And the thing is, even though you are building data centers in a very cold region, you probably don't need to have you don't need to run mechanical chiller 24-hour day. But still, in terms of backup, for the sake of safety and redundancy, and because your data center will be designed for more than 10 years, you have to deal with like extreme hot weather and scarcity of water in some cases, and you probably will face a very big surge of power in the future. So you're gonna still need a certain level of chiller installations. So this is not news. This market does not change after Jensen Huang made that statement. So I think this is very important. First of all, Jensen Huang is not talking about the entire HVAC industry. Data center needs power, and therefore it needs cooling. It has to be something to bring the heat out of the data center. Jensen Huang is only targeting at mechanical chiller. And second of all, I would rather say that mechanical chiller is a little bit at risk because of his statement, but only in a very limited condition. For example, it has to be in a very cold region. The region has stable supply of water, and this data center will not be running super high AI workloads. So only if you meet those conditions where you don't need much of chillers, it can be purely run on dry coolers or cooling towers. But otherwise, in most of the cases in the world, you would still need chillers for backup purposes, for redundancy purposes, for any of the extreme conditions.
Well, I guess, Shen, some people could interpret what you said as, okay, now suddenly all the data centers will get built only in the very top of the northern hemisphere. And
let's look at hotspots: Middle East, Southeast Asia, South America. Yeah.
See, the thing is, even if you're putting a data center in Texas or in the Middle East, in Saudi Arabia, the ambient temperature goes up like 50 degrees Celsius in the summers. And how do you make it like 45 degrees? You need obviously chillers.
The thing is, there's then other conditions that people need to remember, that you need a power transmission network, that you need an interconnect network for the data packets to flow. So there's so many conditions. It's not so simple. And this kind of brings me to one thing that I've been obsessing about. And it seems like one of the reasons why there's an emotional response is there's this movement that has taken over the world, which is this pride in not being technical. I'm not technical, so, this is too much detail for me to be worried about. I'm only worried about the business and the strategic. But the data center industry is a technical industry. If you are ignorant, you will make the wrong investment. If you are ignorant, you will build something that doesn't quite work. And they're really, I do think that, for what it's worth, it is pretty easy to start to build some knowledge, and I think that's very important. And then the last thing from me on the Jensen topic is, it feels like we're seeing this clear cult of personality that we haven't seen for a very long time. I think ever since Jobs, we really haven't seen someone who is at that level, and it feels to me like Jensen has actually managed to get there, and as a result,
he's the new Steve Jobs, man. I think that's a close resemblance that I can actually bring in. Like, Steve Jobs was the king of like consumer devices, right? And Jensen Huang is actually the king of AI now.
All right, so let's move on to the next round of myth busting. It's going to be more related to, these are questions that I genuinely get asked, and I am seeing this constant debate on social media and actually in my calls with clients. One of the big things is there is a lot of naysayers about the AI economy. There are people who believe that it's not real. We're going to get to that. But then there are some rational people who are technical, who are knowledgeable, but they just believe that it is not possible to build the capacity that people want to build. So I guess my first question to you is, can this huge, crazy capacity that we keep hearing in the world, gigawatts and trillions of dollars, can it be built, or is it a pipe dream?
I think that it will be built over a period of time. It's not really something like data centers construction and like setup is not something you can actually just do it like in a jiffy. It needs like time and effort, a lot of planning. Obviously, there are people like Elon Musk who can actually build a data center out of nowhere in like 3 or 4 months. But the rest of the world is not really like that, and it still takes like 1.5 years to develop a gigawatt or like couple of gigawatt of capacity online from the planning stage. So I think that like the demand for AI is real, and people who are working on AI really understand the value of this technology. And even if you look at the adoption trends of AI, those are very positive trends in terms of the token generation and all that. As long as the demand is there, the supporting infrastructure will be built. There are various constraints for like the supply constraints, whether it is chips and liquid cooling, power, availability of DRAM, NAND flash, and other components like that. But even though these constraints are there, it is not going to slow down the capital investments and the builds that we are seeing right now. I don't think that it's going to slow down in any way. As companies pull in more resources and capacity, there will be much more greater investment going into bigger data centers and infrastructure in the coming days.
Manoj, you say that it won't slow down. I get it. But at the same time, people are telling me I can't get power, or the utility, thought that they can do it, but it's not possible, or the regulator has still not finished reviewing my application. So, Shen, do you agree with him? What do we do when there is no power? How do you build an AI data center when you have a power constraint, when you have a water constraint, when you have a labor constraint, when you have even a money constraint?
So first of all, we need to be smart. Building data center is a super rational, super technical job. So we can't just be very emotional, and we have to be very rational. First of all, if you don't have water, you don't have power, then the selection of location of data centers will be super important. You have to find a better place where is rich of power, cheap of power, and rich of water. So this is most important. And second of all is that you need to think about bringing minimum impact on the local grid. Therefore, we think in the short term, you'll be seeing a lot of workarounds, especially on-site power generation. And there are multiple ways of on-site power generation. Let me give some example. In places where it's rich of gas, you can use gas turbine. And in places where you are rich of sun resources, for example, in the Middle East, you are able to use a lot of solar panels plus energy storage systems. The key is to be less independent on the power and bring the power by yourself. It's similar to building a small power plant next to a data center and dedicated to the data center. So this is the short-term workarounds to overcome the power issues.
I think that the only problem is what happens when there is also no gas turbines, because then there is a constraint on that, and then there is no gas gensets because you can't order that because there's a constraint.
Gas turbine is not the answer to everything.
Of course.
I think actually Manoj bring a very important point, is that people would choose, if they don't have power and they have needs, they will find a place where they do have power. Let me give you some examples. So in the past, before AI surge, everybody thinks that a wind turbine is trash electricity, and solar power is also trash because it's low voltage, it's DC, it involves a lot of batteries. So in places, for example, the west of China, people don't like those power, and they even don't want to put that power in the grids. And in southwest China, and there are many 10 megawatts, 5 megawatts small hydropower stations which are not being used or not connected to the grid. So nowadays, what we see that those data center owners are starting to find those locations, buy them or rent them for long term, and utilize those so-called trash electricity to power their data center. It's very cool. It's actually a structural optimization of the power architecture.
Just to add to what Shen said, right? So we are seeing companies like Meta and XAI buying and building generators, gas turbines on their data center premises or close to it in huge quantities. Like XAI is actually building close to around 700 megawatts of capacity on site with gas turbines. And similarly, Meta, who's actually building very large data center capacity, is actually deploying gas turbines from Caterpillar, Siemens, and companies like that. So if there is no power, like build the power capacity. If there is no manpower, fly in the manpower from other parts of the world. And if there is like regulatory constraint, move to the place where you have relaxation in the regulations. So like people want to get it done. So in 2026, we are talking about like power generators, gas turbines and stuff like that. In 2027, there is actually the bunch of guys lined up with their small modular nuclear reactors for the data center world. So it's
Hold on. The small modular reactors, we need to go through a set of regulationary changes and legislation to be completed. So one of the things that I've told a lot of my clients, and I think it's important to reiterate on the podcast, is will we see field trials of small modular reactors before 2035? Yes, we will see field trials, but what they are is trials. They're proof of concepts that this technology is safe before we see large-scale deployments. There is not going to be large-scale relief on the grid before 2035 from a small modular reactor fleet, because you will not see large-scale small modular reactor fleet before 2035.
I'm more optimistic about the timelines. I think there are some trials which is happening from 2027 onwards. So maybe by 2028 or 2029, we'll see like mushrooming number of SMRs. Let's see.
The field trials take many years.
The legislation is a long process.
I mean, legislation has changed over the last few years, and our regulators have changed. I guess these days you can do whatever you want. So from that perspective, maybe things will be different. So I think I just want to close the question about the capacity build, with one comment, and that is, very often an inexperienced forecaster would kind of see a concern around the availability of one component and assume immediately that then the world is down in decline, all the opportunity is erased. Or on the contrary, if there is supply, then we'll amp up to the max the opportunity. In reality, even when there is constraint on the gas turbine supply chain, they're still shipping out because there is still existing capacity. When there is constraint on power, that doesn't mean that all of the ongoing projects are not going to complete, because they've already been discussed. So one of the things that we do as forecasters is we really try to balance this. There are ways to assure that in the short term you got it right. You can triangulate many points. In the long term, you can make some grounded in technology assumptions. But the point is, even if you hear us criticizing capacity challenges on this podcast, you need to understand that does not mean that we immediately think that the world is either black or white. There is a lot of context in between. So let's move on to a question that I feel like you almost, I can tell you're itching to answer, and I can tell that you really want to talk about it, because this has been something that is probably the most frequently asked question that we get, and that is, do we really need this capacity?
Absolutely. Like by now it is well understood that the generative AI is a highly compute intensive like workload, and the various versions of generative AI, like the thinking models and the reasoning models, right? And they actually give you better responses, better like insights, or better quality of output. And when you have these thinking models or reasoning models, it actually takes a lot more compute capacity. And I don't see people going back to the world where they'll be deploying a lot of like dump models, I would say, like the models which are not thinking. And as the context length, as the input that the models will have to digest to give you the answer, as that increases, I think it actually creates a lot more complexity. And when we are talking about like earlier, it was just like text processing. Now we are talking about image processing and video processing and all that. So the compute requirements of all of this is actually going very, very high. So the utilization of the capacity will be, there is no doubt that a lot of capacity which is being built out will be completely used. There is absolutely no doubt about it. I have not seen any enterprise customer who says that some compromises in like models output is fine with me. Everybody wants to deploy the best model out in the world, and that is gonna be compute intensive.
But Manoj, the thing is, you mentioned enterprise, and but the reality is that 70% of the traffic that goes through ChatGPT is not from companies. It is not for work related. I mean, it's actually not from more than 70% is not from companies, but only 30% of their use is for work related stuff. Most of it is for other stuff.
The global internet traffic, 70% of the global internet traffic is entertainment, Vlad. That does not mean that internet is actually not really a technology for the enterprise, right? So
okay, let's think about it then from a different perspective. Sorry, say that I agree with you because ultimately I also watch TV online, but you said earlier, you referred to the dumb models. That's really the knowledge-based AI models. So should we all be using a thinking model? Maybe some of our questions are simple and we can use just a simple, efficient model.
So that's how almost all of the research lab, including means OpenAI, Anthropic, and Gemini, etc. They have a router now. Depending on your prompt, the router will decide whether I should involve a model which takes a lot of compute resource, or like we can, whether I can actually get it done using a smaller model which is efficient process. So almost all of the interaction that you have goes through a router, which decides what is actually the optimal model to use for that particular prompt. So optimizations on these things are already out there in place. So obviously the users are actually given the choice to have a particular model selected for their prompt. But as companies, for them, it's like a cost, right? For them, the cost of compute is actually the real thing. And that is actually what is affecting their gross margin. So they want to reduce the cost of compute, and using a routers to direct your prompt to the optimal model is actually something they have figured out how to do that.
Right, but Manoj, this is exactly why people are concerned. So when most people ask, do we really need this capacity? What they're thinking about is, but AI is going to become more efficient. So are we just going to install a bunch of GPUs that are going to sit idle? When people look at the white paper that DeepSeek published last year, they think, well, look, they managed to do it with very few GPUs. Do we really need all this GPU capacity?
See, the point is, like, DeepSeek mentioned only the number of GPUs they use for pre-training. They didn't really use, they explained the total GPU hours they use for developing the complete end-to-end model. So that is actually one of the biggest, I would say, oversight in that document. And like, people didn't realize the magnitude of that when that paper was published. But I think later people started realizing that, hey, this is not the way to do it. This is not the way to take it. So I think that's we got over that phase, right? And everybody now understand that, like, what kind of compute capacity DeepSeek has access to in China, in other parts of the world, and how do they use that. But it's a very innovative research lab, and they have come up with a lot of innovative methods to optimize the model compute utilization, and a lot of other labs have actually adopted it, and the model optimizations and better algorithms will continue to come out. But I don't think that there will be some magic sauce coming out from any of the labs all of a sudden, which will actually create the demand for compute to drop down like a ball. It's not going to happen.
Shen, can you just address the DeepSeek aspect? So, Manoj is saying that DeepSeek only commented on a portion, but is that true? Because most people don't think that. Most people don't agree with Manoj.
So first of all, the success of DeepSeek is not actually denying the importance of hardware. It's actually a highly efficient utilization of hardware. So a couple years back, it was the largest GPU owner in China, more than any of the cloud vendors. So that is number one. But number two is that how can DeepSeek create so many such a very good model with limited amounts of GPUs because they are innovative on the software algorithm with a hardware architecture. So they want to improve the utilization efficiency of hardware. So this is actually another topic that I mentioned before. It's token per watt. It's not a super big breakthrough of token per watt if you look at DeepSeek case. So until we see a real big token per watt breakthrough, such as in the future, you can use a GPU to run a super big parameter model, which is not likely to happen. DeepSeek and other models are more or less on the same range, but DeepSeek has a much better efficiency because of algorithm optimization. So the hardware determines the top limit of your model, but there's a lot of spaces to do micro innovations to improve the algorithm, to improve the correlation between hardware and software, to do a lot of engineering optimization to improve the efficiency of training or the efficiency of inferencing.
So what you're saying is we do not see capacity risk because of optimization or because, for suddenly there's sudden efficiency or because maybe people stop using it because it's not valuable. But many people don't agree with that. I see that all the time. Even, a few weeks ago, I was at AWS reInvent and I saw some challenges to this. The question really is, okay, so we're building all this capacity to run this all this AI, but are we just wasting our time? Where is the ROI? Because the problem is people see that companies like OpenAI are spending trillions of dollars, but then they see that they make very little money. The second problem people see is they see that enterprises are doing all of these POCs and launching AI in their company, but they're not reaping high ROI. That's what AWS was commenting on. So one of the things they were trying to figure out is how they can make tools to improve that. And then the third problem is that a lot of these investors are these GPU as a service companies, and the GPU as a service market is a very low margin market. These days, the cost per GPU hour is so low. So then if someone like OpenAI has low ROI, if people are not making ROI by using it, enterprises, and then if vendors, suppliers of GPU as a service are not making money on it, there's no ROI, so then what's the point?
So in terms of ROI, AI is a very, very new business, and it just came out from laboratory to the real market for 2 to 3 years. So it's a very, very new, and it is too early, in my eyes, it's too early to talk about specific ROI, while the technological paths and market model are not yet very stable. So we are still seeing the tokens are being exponentially needed, and we are still expanding our capacity, and potentially a lot of business models to be discovered. So if we look at very low ROI or very low gross margins, because if you simply rent a GPU out, it's nothing different from renting your real estate out. So this business model is a traditional business model. It has nothing special and nothing innovative. I think the game changer would be adding more values to a service. Think about more rather than just renting GPU hardwares. So there's a lot of space of imagination.
So my question is how do you calculate ROI? So to give you an example, a couple of days back, I watched a YouTube video about ASML's EUV lithography tool. So EUV, or extreme ultraviolet lithography, is actually a technology which is developed in 1990s. And how to use this EUV in a production system for etching very smaller transistors on silicon, that was actually a challenge, and it requires a lot of R&D and investments. So everyone was actually questioning the ROI all the period that ASML was actually working on it, and they often struggle to get funding to continue the research going. And I think that after close to around 20 years, they shipped the first EUV tool to Samsung, and till that time, people were questioning the ROI on all of these investments. But imagine the moment after 2016, EUV was launched and EUV was proven as a technology to shrink the transistor sizes for the subsequent generation of chips. None of the technology that we consume today would not have been there without that particular machine, which actually could print nanometer scale transistors on silicon, right? So some people are like they want to put $100,000 today. From tomorrow, they should seeing the money grow from that 100,000 to maybe 120 or 130. That does not all technology work, right? It actually takes time and effort, investments. But the people who adopted it and the people who are actually developing it are sure about the benefits of this technology. I think a large part of the world really appreciates the technology and are really positive. That is why we are seeing all these investments happening, right? But obviously there are naysayers for everything.
Well, there could just be hype, right? So, by the way, I'm playing a devil's advocate, but actually, I think that the problem of ROI is actually a problem of how you pose a question. To me, what you said about ASML is it's like the proof is in the pudding. Look at ASML; they are unchallenged, but the ROI was 20 years. So the time for measuring ROI very quickly. Typically, people look for ROI in 5 years, and they're happy with ROI of like 1-2 times whatever.
Generative AI is not 5 years old yet.
Exactly. And the thing is, in 10 years, you could reap huge ROI. There could be, different ways of working. So for me, how I asked you the question is wrong. And I asked it like that because that's how I get asked. When people ask me, look at OpenAI spending trillions of dollars, but they only make a few billions, that's a choice. They've chosen that this is their current monetization strategy. They could monetize it differently. They could charge more in the future, like how Netflix and YouTube started to monetize it later, or how Google later started to have adverts on their website. One of the things that Manoj frequently reminds me is that Google originally didn't have a monetization plan, and they eventually started to get money from adverts and became one of the richest companies in the world. So I think that we do not yet have clarity on the OpenAI business model and how exactly they will monetize it. I think for now, they're focused on making this technology ubiquitous, and then monetization will come later.
They're already making money, huge money on AI. I think OpenAI is one of the startups to hit like $10 billion revenue mark in the shortest possible time in human history. So I don't agree with the fact that they're not making money. Obviously, compared to the investment they're betting on, it's actually smaller, but they're getting there. Like their growth is substantial.
I can phrase it in a different way. You say they're one of the startups to make billions the fastest. I can say they're one of the startups to spend trillions the fastest.
Absolutely.
But I think that that's a choice. I think they could make more money if they wanted to.
Exactly.
I think we agree on that. So I think there's no disputing that there's a big gap between their revenue and their spending. But I do think that their revenue is a choice. I think it's a sacrifice in the short term so that they gain market dominance. It's like buying market share in a way. And I think that one of for me, the reasons why they're doing this is also the answer to the second question, which is why are enterprises not seeing higher ROI? So many of my analyst colleagues quote the MIT research that so many of the enterprise POCs will fail. I think that the reality is that many enterprises rushed into projects with early technology and with not the right mindset.
The right tools.
Exactly. And also the cultural change is so difficult. The cultural change is very difficult. And I think that we've seen time and time again in the enterprise world, cultural change happening very slowly. That's why so many companies fail, actually. If I think about, why Intel failed, I think there was a cultural change problem that occurred over many years. But I think that's actually the root of the enterprise ROI problem. I don't think it's the technology. I think it's how we're trying to apply it and what we choose to do with it.
Yeah, see, the point is generative AI is a very new technology, right? And there are not enough expertise who's working on generative AI in many organizations, to be very frank. And a lot of them are actually using like third-party tools or like SaaS kind of services to generate value. Obviously, when the cost per tokens were absurdly high, that was actually the case in like early days of generative AI, right? The cost per tokens were pretty high, and now it's like dirt cheap. But when you are actually evaluating the projects during a period where the cost per tokens were pretty high, obviously it is like there is a highly likely chance that most of the projects which they started off didn't really create the ROI that they were targeting. But That is not the scenario now, because like the cost per tokens have actually gone down multiple order of magnitude over the past three years, and that is actually a big change. Right now, the tokens are very, very affordable and accessible. So when you have like highly accessible and affordable tokens, using that to productivity gains or optimize and your or use it for your R&D and all that makes more sense. So maybe the report came up like last year or maybe somewhere mid last year about the studies they have conducted in 2024. I'm not really surprised that it generated a highly negative image about like generative AI's ROI. But if you do the same study now, I strongly believe that this scenario will be completely opposite. And that is something that we are seeing now. A lot of like enterprises are adopting AI for either cost saving or like productivity improvement or like R&D projects or to come up with completely new kind of services. So
I actually think that we're missing something. So we've talked about how you deploy an app and how an app gets monetized that is dedicated AI. We've talked about how an enterprise deploys an app and how and the app is an AI app and they prompt it and they get money. But
so this is not just like about like using somebody else's app, right? I can actually create my own app. For example, I want to have a food delivery at home, and I have like these multiple service providers who's having for example an API. I can actually develop my own app for my own smartphone and like get the best deal out of all the other apps, and like I can enjoy that service, right? That is like, and I'm not really a software engineer. I can actually talk to an AI, then develop that kind of an app. So that is actually the change that generative AI is actually bringing. A lot of people don't realize it, but I think that it becomes an obvious thing going forward.
Yeah, AI will break the technical barriers of knowledge and the barriers of skills.
Talk to us about your experimentation, because you shared something with me on Monday that was very cool.
Yeah, I was trying to do something to my computer, and I want to extract a lot of the data from the database that I have. So I asked AI to write some script, and AI did it for me. I just clearly tell it what I want to do. Then I copy paste the script to my PowerShell in the Windows, and it runs and it works, and it gives me a Excel file in which I have the data I need. This is example, and this is just the beginning, because script or PowerShell is still a professional tool for non-IT people. So in the future, you'll be having a window, and you can just tell them what to do, and they can do whatever for you. You can create tools for you. They can gather the numbers for you, and they can analyze the number for you. So think about, in the past, only professional people can do these kind of things. Only software engineer can do a software programming. Only electrical engineers can draw a schematic of electrical systems. But in the future, have some imagination. So the barriers of knowledge, the barriers of professional skills will be broken. Normal people will be able to do whatever they want using AI tools. So we need to think about these kind of future applications when we talk about ROI, when we talk about gross margins. So long term, there'll be a lot of imagination spaces.
The truth is that we are thinking too small.
Yes.
We're thinking too small, and it's not just about using a dedicated tool that you prompt and you get some results. It's also about being able to generate apps and programs that you can use even though you don't know how to code. And also it's about AI functionality being integrated into apps without our awareness. And it's just that the app functionality that we're used to gets better, like the maps and the whatever different services that we access via apps.
So I just wanted to add one anecdote from Jensen's, I think, Q&A during CES. Like, so the way apps were working, or like the old generation like software was working, is completely different from how a generative AI is working. Like, so when you are actually working with a software, a traditional kind of software, a cloud software, take an example, it's actually pulling data from some databases, or it's actually just doing some processing which it is programmed to do and showing you the result. But when generative AI is actually doing the work for you, it is actually creating data. It's actually coming up with data which is non-existent, whether it is image, whether it is like a response for your prompt or your question or your query. It's actually completely newly generated text. When you're opening a Wikipedia, it's already a page which is actually stored in the in one of the Wikimedia servers, which is actually being shown to you. But when you're talking to Gemini or ChatGPT, the tokens that you consume are newly generated every time. And that is exactly why the generative AI is so compute intensive. It has to generate the tokens every time, the tokens with your context every time. And that is why we need all of this infrastructure for.
I think this is a good place for us to pause. There's obviously, we could talk about this topic for a long time, but we want to show our trends to watch. So that will be part 1 done. Let's continue the conversation with the 2026 trends to watch. And we really want to explore the different aspects of the industry.